All right, so Denis, I I recommend you follow uh my steps as we go through this. So today we're going to run through our Smart Aquaculture deployment automation to OpenShift Local, which has gone through a lot of work to make it really automatic. So getting started, you can go to my site, computate.org, and down here, there's a link to deploying Smart Aquaculture on OpenShift Local and install OpenShift Local on your own computer. So if you haven't already installed OpenShift Local, you can follow this document and you can get it running on Microsoft Windows Pro or your version of Linux, and then start deploying Smart Aquaculture on OpenShift Local. So since we've gone through some changes in the database structure and the search engine structure for how things are done, we need to delete our existing OpenShift local. And I hope this never has to happen again. Something else that we did was we migrated away from Bitnami proprietary container images because just in the last few months since August 28th, they they used to have hundreds of free container images to use, including Keycloak, Zookeeper, and Apache Solar. And all of a sudden on August 28th, they said, these are no longer free. You have to pay for these, and we're only going to have these deprecated versions that are archived. And it's basically a big disaster to all developers, including our project, except now I've gone through the work to migrate away from Bitnami, and now we use operators. So we use the key cloak operator, and there's docs for that. We use the zookeeper operator, which is this Pravega zookeeper operator. And then we use the solar operator, and yeah, so that's this operator here. So because we stopped using Bitnami, if we try to keep with our existing OpenShift local environment, it's going to be all messed up because there were a lot of changes under the hood. So it's easiest to start over. So feel free to follow along, Denis. I'm going to do CRC delete and say yes. This will delete my instance.
Hey, Chris,
Yes.
this could also be a good hackathon. If you ever have to start over and do a infrastructure change, this could be quite a lesson.
Yeah. Yeah, this is a good lesson. Um, we in the open source community, you gotta stay ahead, and sometimes that makes for some difficult decisions. Um, so we had to make some decisions on what we're going to do about Bitnami images, um, and so what I had to do, I'm going to get this started. So I'm going to start my new OpenShift local and show you um, what I had to do to enable the Solar operator to work in OpenShift, because the Solar operator hasn't worked in OpenShift for anybody. Um, and I knew about this um, because I tried to use it back in May 2024, and even before that, and it wasn't working for me because of the security context and the way it's done in Kubernetes. So there's a difference the way that security contexts are defined in Kubernetes, where you have to put specific values. But in OpenShift, they magically take care of security context, and all you have to do is add an empty object, and it just works in OpenShift. It's kind of magical. But Solar would always deploy it the Kubernetes way, and it would always break OpenShift. So they were telling me, okay, can you implement OpenShift support in the Solar operator with this auto detect feature from Grafana? And so, because I made a pull request, but they rejected it. They wanted it done the auto detect way. So finally, yesterday, um, I got it working. And so now we have this contribution upstream to make the Apache Solar operator run on OpenShift. And I've deployed my own image for that at quay.io/computate/solar operator for people to use. So that's what we're using right now until this gets merged upstream.
Hey, this is a great skill. Operators are a great workforce skill.
Oh yeah, operators take care of a lot of trouble. So, um, operators are built to automate things, and so it's basically automating solar as much as they know how. And we just have to provide some simplified, it simplifies our work. Um, anyway, this is how we're adapting. And now I just need this OpenShift local to come back up. The operators are becoming ready. Um, I've made a I've made a bunch of commits to github.com/computate-org/smart aquaculture. Uh, because these are changes that I'm trying to bring into all my projects, AI telemetry, smart aquaculture, my own website. And so we have updated OpenShift local deployment. Um, resources, and we set up the smart aquaculture secrets. We set up the service route and deployment of smart aquaculture. And these Argo CD applications take care of all that and set things up for the cloud or in OpenShift local. So that's what we're going to run as soon as our OpenShift local environment's ready. So if you haven't installed OpenShift local, then you can install that course. Otherwise, we're going to follow these instructions. And I'm running Red Hat Enterprise Linux, so these are my instructions here. And okay, so OpenShift local is ready.
And you're
Excellent.
running Red Hat version 9, right?
Version 9.
Yes, that's the enterprise level you're running.
Oh, yeah. So I am running, yeah, so if I do fast fetch, it says OS Red Hat Enterprise Linux 9.6. So I like version 9. I haven't, version 10 was released in May at the Red Hat Summit, but I'm not ready to upgrade to RHEL 10 because I found it hasn't received support for they removed some display drivers related to X11, that caused me some issues with some of my programs. So for me, it's not ready yet. But Red Hat provides releases every May and every October, I think. So there should be a new release coming out soon that may be good enough to migrate to Rel 10.1. We'll see. All right. So I have already created the GitOps directory. I've cloned it and I have a terminal open here to computate GitOps. Oh, let's see. Actually, I didn't want to close that. Well, that's fine. All right, so then I go to my GitOps terminal, git status. Yeah, git pull. Make sure I got the latest. All right, we're good. So I apply OpenShift Local / GitOps / base, and this is going to install Argo CD or the GitOps operator. Okay, and then if I go to installed operators here, we can watch this become ready. Right now it's in status unknown. So we got to be patient for this to resolve. And then this GitOps operator is going to unleash some real potential for deploying applications very quickly.
Yeah, that's what the world wants. Speed, speed, speed.
Yeah. So wait for it. The other way to wait for it is by running these commands in the terminal. Let's see if these it hasn't found the resources yet. So we got to wait for this operator to become ready. Um, Unavailable. So sometimes when you have a brand new OpenShift local, you the operators don't work because the catalog sources are messed up and you got to reboot. Catalog source. Let's see, show all projects. Red Hat operators. Says it's ready. Okay, that's good. Let me try this. If I do delete, it goes away. And then let me apply it one more time, see how it goes. Okay. There, now for some reason it's working now.
And so this is reinstalling the Git operator. Okay.
Yeah, GitOps operator. We need this to automate a bunch of stuff to make it easy.
So I guess we're going to need a section of operators we need too, and then you got to explain to people what operators are. Like when I was in the OKD working group, we were doing the same thing because we were trying to go into the pipelines, and ooh, tech time just was killing me. But this is great, you know, it's very powerful.
Yeah. Yeah, I've already discovered the helpfulness of operators this week when Bitnami totally failed us and started changing things under the hood. And I'm like, why isn't my solar pod running anymore? And it was all Bitnami's fault. They changed something under the hood. I'm like, I gotta get away from these guys. They're changing everything. And and so this operator, all these operators are still maintained by communities trying to run things cloud native um, in Kubernetes in OpenShift. So that's just that's where we got to be. Um, so now the GitOps is still becoming ready. Yeah, it's still installing here. So we got to wait for this to finish. It says succeeded, and so did this command. And then we run this next one, make sure this is ready. So now the controller is getting ready. Um, if you want to see where these pods are that are getting ready, you go to workloads pods, switch to the OpenShift GitOps, except you got to show default projects, and then it's here. And so these are still container creating, initializing. So that's why we're still waiting here. These things to become ready. Okay, everything's running now. This just needs to become ready. Okay, GitOps is ready. Uh, moving on to the next steps. We apply all of our GitOps. So we copy this and paste it here. And then we watch the fun begin. So I'll copy this command and okay, so then access Argo CD, log in, allow. All right, so it put this in. Okay, so now I think I need to update my documentation a little because I used to have this auto sync, but when I was troubleshooting solar, I was trying to delete solar, and because this was set in an auto sync state, it would not let me delete it. I would try to delete it, and then it would just deploy it back. Delete, deploy, delete, deploy. And it was like, it was too much trouble. So I decided I need to not make it auto sync and instead um, I want to make a change to the course. So this course is called Deploying Smart Aquaculture on OpenShift Local. So I go to my Smart Aquaculture source code and find that file and look for access Argo CD. Um, uh, find the in cluster AOA application in Argo CD, or click on the in cluster AOA application in Argo CD. How's it going for you, Denis? Are you following?
Uh, Following is big word.
Have you deleted your OpenShift Local CRC?
No,
Okay, you're gonna want to do that to continue development because so many things broke since, or there were so many breaking changes in the past 2 days
yeah.
that you're gonna want to follow along. Well, I mean, it, you can do CRC delete and CRC start and get a clean OpenShift local environment.
Chris, what does CRC stand for again? I forgot.
Code ready containers.
Yes, yes.
And it's kind of the upstream name for OpenShift Local. OpenShift Local is the Red Hat name. CRC is the upstream community name.
Yeah, that's what gets me. Yeah, I got to know my upstream. Yes, yes, that's important.
Yeah, I'm used to it at Red Hat. It's like, wait a minute. What is this Red Hat product? Oh, that's what it really is? Upstream? Okay, good to know.
Yeah, that's half the battle.
Yeah. Yeah, so I need to say, let's see, I'm gonna do a OLLI. Click the link. All right, click sync. Uh, click sync. Um, click synchronize. Synchronize. And then this is going to go install a bunch of stuff. Uh, so it started with deploying a few applications, and then all of these applications turn into other things. So we look at all the applications now. We used to have one that was the app of apps, and now we have all of these. It's wild. So it's doing all this multitasking. And what we really need first is everything with Vault. So we want to see Vault become healthy and synced. So some of these things have synced. The Vault operator and the base Vault resources.
And this is
Progressing,
critical.
uh-huh.
Chris, I was saying Vault is critical because of our secrets, managing our secrets.
Yes. Um, See, because we don't want to become vulnerable like what happened to the NPM community with massive self-replicating malware worm. It's really bad. So we're keeping things secure by keeping our secrets in Vault. Um, Also, if a secret gets exposed, then you want to change that secret, and Vault will automatically sync that secret to your cluster, and then your applications will have the updated secret. So even if you get exposed, it's easier to react to um,
So, Chris,
to
this is
that.
valuable cybersecurity training with secrets for your architecture.
Yes, I agree. Um, so what's happening here is it's deploying Vault, and if we go to Vault, um, this pod is almost running, so it's becoming ready. And then there's also going to be Vault secrets. So yeah, it hasn't given us our unsealed password to get the vault unsealed. Actually, the vault, it's going to unseal itself automatically. We just have to be patient for these things to become synced. Uh, so what's happening here? We have Vault running. Well, okay, it's still not ready yet, so it's still like setting itself up.
So is this more like, remember when they say day one operations? Is that what we're doing, or is that something different?
Yeah, I think so. This is
Okay.
this is day one is getting all these services up and running, which we've already automated. We're going to be way ahead of the curve when by getting an allocation in the MOC, we'll be able to um, deploy this stuff and get up and running.
Image full black call. That's an interesting name.
Yeah, so is trying to pull Queta.io, NERC images, Keycloak Ansible latest. Um, I think it'll try again. This vault not initialized. Still just getting everything ready. Part's kind of boring. I think it found the container image, yeah. So it was able to pull this down, but it's failing because it can't connect to Vault yet because Vault's not ready. Um, all of this takes some time. So you're talking about what operators we need. So a few of them have already been installed. We have the Vault config operator. We have the external secrets operator, the namespace configuration operator. These are all Vault related. Then we have GitOps, and then we have Postgres, Crunchy Postgres. So those are installed. Oh, okay. So vault is ready. The vault unseal vault completed. And the vault setup completed. So that's good.
Ah.
And it ran it 3 times. I guess that's okay. Okay, so that's good. That means that other applications are now gonna get ready, like Postgres. So Postgres has a secret for let's manage by okay, wait, maybe that okay, Postgres, Keycloak. Keycloak is an interesting one. So Keycloak initial admin. Oh, that's managed by Keycloak. Okay. And then is it running yet? Create container config error. Events. Successfully pulled image. Error secret Postgres PG user Keycloak not found. Yeah. Um, so we're trying to find this secret, but it's not there yet. So if we look at this app setup, database setup, okay, database setup is running and failing. Let's check. So undefined variable. I think um, what this is looking for right now is some vault stuff. So we search for secret and we pull up secret store. External secret and secret engine mount. Let's check on the status of these. The secret store in Keycloak, secret engine mount. It says unable to create client. Invalid role name, KV engine admin. Last reconcile succeeded. Secret store. Store validated. So Vault is resolving its earlier problems right now, right before our eyes. And um, and then there was a external secret, or there was a random secret. Let's see, random secret. So this random secret needs to get created. Reconcile successful, true. And then there's an external secret. Postgres user Keycloak. Cannot get secret data from provider, but I think it's actually there now. Um, I'm going to grab the vault root token and go to vault.appscrc testing and log in. All right, so update. So Keycloak has this Postgres PG user Keycloak password, and it generated a password for us. Vault can generate passwords. And then we just need this external secret to know about it. And this external secret, refresh interval 15 seconds. So I feel like it should be able to sync that. If I could delete it and it'll probably resolve. Okay, I didn't have to delete it. The secret was synced. And um, now this database setup pod can run. So this database setup pod is going to restart sometime soon. Um, it will restart, but I'm just going to delete it so that it starts right now. So then, because that database secret is in place, it's able to complete. So that got completed. And then let's delete this pod and let the app setup do its work. Actually, that's not going to work until Keycloak is running. So Keycloak is now running. And it will be able to connect to its own database that got created. This is how Keycloak starts. It's initializing its own database. And then it actually reboots, probably because it just created a bunch of database tables and then it's like, okay, time to reboot. So then it reboots. And continues its initialization. How's it doing now? Oh, it's running. Okay. Yay. Okay, so it's ready. And what else were we waiting for? So we can look at the application list. I should try to look into why these might be out of sync, but I think it's looking pretty good. So maybe, yeah, the app setup Keycloak worked. So I think we're ready to move on and let me close some tabs. Now we deploy Smart Aquaculture. So I go to my Smart Aquaculture clone and run this command. So that just created some new Argo CD apps. So I come to the application list and search for Aqua, and these are now progressing. And if I go to my Smart Aquaculture project, you see these containers creating, and there was a database password generated from Vault. You can see it was reconciled by external secrets operator. So this came from Vault, and if you look in Vault secrets, yeah, it's got Smart Aquaculture here. So it has that Postgres password from Vault, and then it's going to start running its pods. So cloud setup needs to run first, and then the Smart Aquaculture site can run. So it goes and creates the database and a solar search engine collection for Smart Aquaculture in the cloud, and configures Keycloak, configures Zookeeper, uh, context broker. We can configure Font Awesome so that we can add our Font Awesome kit. So this completed. Nice. And then we go to pods. We see Smart Aquaculture is getting ready to run. So it went and updated the database schema for Smart Aquaculture, and it granted itself a bunch of permissions in Keycloak, and now it's running. And it goes and imports a bunch of docs, doc data automatically from Louisiana, fish processing plants and fishing docks, and then it goes and imports all the time zones in the world because we want to work with time zones. Although looks like there's a little bug that's happening here. Gonna have to look into that. Oh, that's fishing dock. Yeah, so we got a few bugs with the import process, but that doesn't stop it from running. So it's up and running. And then we just go to the networking routes and check out our site running locally. Yeah. See, we got it up and running. Now the other thing that we're doing is we are creating a course for people to learn how to become a smart aquaculture developer. And I'm still working on the course. That's my goal, is to work on this course now, but I do OC apply -K, and then I do applications. And now if I go to the application list, there's some new applications popping up for local setup. So this local setup, let's see, error. Oh, okay. So this is what I got to document here, because this is a private repo. So we connect a repo via SSH. We say Smart Aquaculture Developer and put it in the default project. And then the repo will be developer. This is the repo, and now for this part, I need to copy my SSH private key. So I'm gonna stop sharing. We want to keep things secure, not expose any secrets. Connect, and then I'm going to connect one more repo. Computate.org developer default and the repository URL. developer code, copy repositories, that, connect. All right, now I can show you what it looks like. So then share my screen again, share. All right, so I have these two repositories in Argo CD configured that point to get repositories through SSH. So they're successfully connected. And now if I go back to applications and search for Aqua, then this is the local setup one. And let's give it a refresh. Okay, so now it's able to connect to that private repo and start syncing. So it's going to start running a job, the local setup job, close pods. Local setup is running. So it's going to set up all the same stuff that it did for the cloud, except a new database and a new search engine collection for local development. Because I ran into problems earlier. This was another bug I resolved where the local was trying to share the same database as the cloud that's deployed here, and they were conflicting, and it was kind of a mess. So with that local deployment in place, then what I can do is let me save this. Okay, so I'm going to delete this stuff because I want to show you what comes next. Wait. Actually, no, I need that stuff. So then I'm forgetting how this works. So then what we're doing is we're going to have some Jupyter notebooks in this Smart Aquaculture developer project that helps you configure your VS Code settings. So we're going to configure use ignore files false so that we can see all of our files.
I'm just then we need to put down customized VS Code customization. That's an important selling point.
Yeah. Otherwise, VS Code will drive you crazy if you don't have
Yeah.
it configured just right. There's certain extensions that we need that we can also configure. I didn't quite get to that, but we'll do that. And then we got to install our dependencies on our computers. So installing Java 21 as a dependency and updating our Java home. This helps us close. It teaches us how to fork our. Oh wait, that should say Smart Aquaculture. So I'll have to fix that. But it teaches you how to fork your Smart Aquaculture repo so that you can be a developer and set the upstream remote and things like that. So that's a step that I've already done here. And then this is for installing all of the code generation, and it explains it along the way. So the computate code generation libraries, that's what this is about. And then that one needs a rename, but this is so what's cool about this part is if I let's see, if I do rm.vscode, no wait, cd rm.vscode, there's this launch.json, and I'm going to delete it. So we don't know how to run Smart Aquaculture until we run this Jupyter Notebook. And so I'm just going to run all, and this creates a symbolic link from our course to Smart Aquaculture, and then it also sets up the run configurations. So ls.vscode. Wait, looks like that didn't quite work. Oh, let me think. Status code. Service not available. Let me see why. Oh, okay. So let's check on Apache Solar. This is the newest. This is running the newest operator. So Solar is running, however, the ingress routes. It didn't create a route. So I'm gonna have to figure out why, but if we create the route manually, solar, wait, let's see. Solar hostname, this service, solar cloud common, select target port 80, secure route, termination edge, insecure traffic redirect, and create. Then now it's working. It's asking for a username and password. So then let me come back here and launch this again. Oh, let's see. Vars.py chmod plus x vars.py. Okay, a couple bugs to fix. The solar route and the permissions on the vars.py, but now it's automatically configured our launch configuration. What's really nice about this is there's no secrets anywhere. All the secrets are in OpenShift and in Vault. So there's no secrets related to smart aquaculture on my computer at all. Because what we don't want is vulnerabilities.
And that's the main, and that's a zero trust compliance thing, right? Also.
Yeah, I would say so. Uh, keeping things as secure as possible so there's no data leaks. And so if I run this, oh, let me stop it, run it, clear. So this is going to run Smart Aquaculture. And what's cool about this is that I can now view Smart Aquaculture from my localhost 10230, and I can develop this effectively from my own computer. So if I look at this part, launch, let's see, Argo CD, access Argo CD. So I added some additional steps locally to click on the in-cluster AOA application in Argo CD. If I look at the same document from the container image that was built, which is deployed here, and I go to the Smart Aquaculture here, and I do access Argo CD. Let's see, this one here. Um, so this one has those steps that I've developed locally, and this one doesn't. Um, but then I can commit this code, and then Quay.io is going to rebuild my container image for Smart Aquaculture, this one here. And it's triggered by commits to the main branch or pull requests, and then it'll deploy the latest article. So we can do local development. Let me just show you for example. So I go to, what is this article called? Deploying Smart Aquaculture on OpenShift Local. Access Argo CD. Where were those lists of things? OL. Yeah, these things right here. So if I delete this one and refresh this page, then there's just item 1 through, where'd it go? Access Argo CD. Wait a minute. Where'd it go? Synchronize. Right there. And then I delete it. Yeah, so that just shows 1 and 2. And then I add a third one. And then it's got 1, 2, 3. So I can do local development on my own computer this way, which is so easy because we automated everything. Like, it took a while, but we did it in an hour. We became a smart aquaculture developer in 1 hour. Pretty cool.
Awesome. Awesome. So it sounds like me and Danny have some homework to do on operators and external secrets and internal secrets, right? Because we address both of those issues, and we got to explain the difference between internal and external secrets. I think I'm not sure.
Yeah, so the external secrets mean the secrets come from Vault, and then they get created as a secret within OpenShift, but they're directly connected with Vault. So external secrets come from Vault and create a secret within OpenShift, and then OpenShift can read the secret and connect it to a container.
Okay.
But it's the most secure way we can do it. I don't know a ton about confidential containers, except when I was working in the bank, the way they handle secrets is everything is queried at runtime. So it needs to be like an approved application from a certain IP address or something, gets approved from a ticket management system to receive certain credentials. And then that application, when it starts, it makes a request to their secret management system, retrieves a bunch of secret values, and then sets them as environment variables in the container. And then the container finishes starting up after getting its environment variables applied, and then it's able to run. And the secrets are actually never stored in OpenShift at all. So that's kind of the next level of secure.
Wow.
It can all be done at runtime.
Amazing. Thank you so much for your time. Um, I think you just sent me some more corrections. So I had to go get those, we might be in the final stage. So I'm just making sure that's good. But this is awesome,
Nice.
man.